Okay, what we're going to start out with here is in pre-calc and in calculus a lot, we try to look at problems from different standpoints. And we're going to look at three standpoints particularly today. One is a numeric standpoint. Okay, and when we talk about a model, okay, what a numeric model is, okay, is something where we have numbers that need to be analyzed. Okay, generally come from some kind of data that's been collected. Okay, and the key issue is what are we going to do with that data that's been collected. Okay, so first of all we're going to analyze it. Okay, and the reason we would want to analyze it is to gain insights into phenomena. Okay, it might be something that we've collected for a business. Okay, it might be something that comes from science. Okay, lots of different applications that we use mathematics for. Okay, and a lot of times the information that we get, okay, is going to be from data that's been collected. Okay. Now, we are probably most used to what we call algebraic models. Okay, and the key with an algebraic model is that we are generally working with some kind of formula. Okay, and so as we go through this, we're going to kind of develop some relationships between numeric, algebraic, and then we'll talk about the third in just a minute. Okay. So ultimately, we use formulas to relate variable quantities associated with the phenomenon being studied. Okay? So I may have a table of data that's collected that might represent, anything. Like I said, if it was, if I had something like time versus money, okay, and I was given the numeric data that for at time 0 we had, let's say $10. At time 1 we had $25. At time 2 we had $40, and so on. Okay, if I notice that with the information given here that there's seems to be a pattern with 1 hour and it looks like it goes up by 15 each time, okay, we should be able to write some kind of model, some kind of equation for this, okay, to put our situation into an algebraic form. Okay, right now, okay, it's in a numeric form. All we know is the data. Okay, but if we were able to write a formula for the data here that would represent that, then we could use the formula to make predictions. Okay? And that's kind of the gist of what we want to be able to do, because the data collected, okay, will help us make decisions about what we're going to do for our business or our science project, whatever the case may be. All right? But again, so part of our issue today and over the next part of this chapter is going to be taking a numeric form of data, okay, and changing it into an algebraic form so that we can use the formula that we create to make predictions. Okay? Now, before we look at the third type of model, I'm going to take a look at an example real quick. It says it's comparing pizzas. Okay. We have a pizzeria that sells a 20 by 20 inch pizza for the same price as its large round, which is a 24-inch diameter. And it says if both pizzas have the same thickness, which option gives you the most pizza for your money? Okay. So with our information given, okay, we want to think about what the situation for the rectangular pizza. Okay, think about what would make it a better buy here. Ultimately, if they have the same thickness, okay, if I want to compare the amount of pizza I actually get, and think about what quantity would we want to find with these two. Brandon, what do you think?
Area.
Exactly. If I found the area of the rectangle and I found the area of the circle, okay, we could compare those two and decide which one is the, essentially the more pizza for the same amount of money. Like I said, the price here is the same. So we know from geometry, okay, we can take an algebraic approach to this because we have formulas for those two shapes. Okay, we know that area equals length times width in the rectangle situation, and we know that area equals pi r squared in the circle situation. And so in our case, if we go ahead and calculate those two, in this particular case we get 440 square inches, 20 times 22, 2 dimensions. And then we do the r squared. Keep in mind that we got to make sure we don't put 24 in there because they told us the diameter was 24. So really the area is pi times 12 squared, and it turns out to be 452.4 square inches. And so with that said, okay, we can decide which one's the better buy. This one, obviously, we get more pizza than we do in this situation. Okay. Now, keep in mind what you don't get with the circular pizzas. You don't get those nice corner crispy pizzas like Jets has, right? Okay, so would it really be worth that much? I don't know. It's a good question. That's a debate for the ages, right? Okay. All right. So, like I said, in this particular approach to solving that problem, okay, we had some data here, but ultimately we used an algebra approach because we have formulas for those two quantities, which we were able to do and compare. Okay. Now, the third type of model, okay, that we can look at to compare things, okay, make predictions with, is a graphical approach. Okay. A graphical approach is a visible representation of a numerical model or an algebraic model, okay, that gives insight into the relationships of variable quantities. Now, I want to look at both of those parts because they mentioned the other two models in the definition here. Okay, ultimately, if we want a visual representation of a numerical model, okay, going back to that model I had earlier where I had 0, 10, 1, 25, 240, and 355. Okay, if I were to plot those as points on the coordinate plane, time versus money, okay, I could get a visual of what's going on in that situation in terms of how those relate. Okay, in terms of how the time relates to the dollars. Okay, and if I did that, okay, my graph in this case I'd have 0, 10, and I'm just going to draw real roughly here, 25, 40, 55. If I graph those, okay, that might lead me to believe that the situation here is, what kind of graph might this be if I have these points graphed as such? Looks like a what? Yeah, looks like a line, doesn't it? Okay. So based on our data points and graphing them, we might say, well, a linear model would probably be pretty good here. Okay, and if I recognize that a line would be a good fit for these points, okay, then I can go to the algebra and I can actually write an equation for that line. Okay, because I know if I'm going to write an equation, I just need a slope and a y-intercept. True? So I should be able to come up with both of those things when I have these points. Okay, and then after that, I'd have an algebraic model because I'd have an equation, y equals 15x plus 10. Okay. Now I just found an algebraic model for this situation. Okay, recognizing that 0 in here would give me 10, 1 in here would be 15 plus 10, which would be 25, 2 in here would be 30 plus 10, which would be 40, 3 would be 45 plus 10, which is 55. Okay, and so now not only do we have a table of values, a numerical, okay, we have a graph, okay, and we also have an algebraic model, and all of these represent the same situation, don't they? Alright, so what we're going to do here in just a minute is I'm going to have you do a few problems in a minute where your job is going to be to take a look at all three versions. Okay, if you turn to page 81 with me, it looks like this. And you'll notice that on the left-hand column, okay, we have a table of values, okay, the numerical representation of the situation, whatever it may be. Okay, they didn't tell us that it's about money or time or anything like that, but it's just going to be some random situation, whatever it might be. And what our job here in this first part is going to be to just take a look at the table of values. Okay, compare it to one of the graphs that we have over here. Okay, decide which graph goes with that table. Okay, and then once we decide which graph goes with that table, see if we can come up with which equation goes with that graph and table. Fair enough? Alright, so if you need to, okay, based on what you know about, most of these are either lines or parabolas, so it should be fairly easy to determine which graph goes with which equation. Okay, if you need to, though, you can graph these equations and see which one is the right graph that it belongs with. Okay, you'll notice that each of the graphs has a window on here that you can see. Okay, so that if you want to graph any of these in that window and make sure that it looks right, you can do that. Okay, so what we're going to do is I'm going to give you about 10 minutes right now to work on this part. Okay, this 1 through 10 group, we're going to do all of these, okay, as part of our homework today. So I want you to work on these right now for about 10 minutes, and then after that time is up, then we'll discuss and see how we did.